Hello everyone. In this video we are going to solve question number 27 of GATE 2020 physics paper. The question is, let us have three vectors e1, e2, e3 which belong to some three-dimensional real vector space, and then we have to find that which one of the following option is correct. So we know that in a linear vector space, in an n-dimensional vector space, if we have vectors v1, v2 up to vn, then they are linearly independent. If they are linearly independent, then these vectors are called the basis vectors, or the basis of R cube. That is where R cube is nothing but a three-dimensional real vector space. So for this three-dimensional real vector space, these vectors will be called bases, and any other vector can be represented as a linear combination of these basis vectors. So that is the essence of basis vectors. Now, in a three-dimensional case, in order to prove the linear independence of any three vectors, we just need to find the volume occupied by these vectors, because if all these three vectors are linearly independent to each other, then they would occupy a finite volume in this 3D space, and volume occupied is nothing but given by the scalar triple product. Volume occupied by these three vectors will be nothing but the scalar triple product of these vectors, which is nothing but given by the determinant formed by these vectors. So we'll just find the determinant formed by these vectors, determinant of the matrix formed by these vectors, which will be 1 0 0, 1 1 0, and 1 1 1. The determinant is 1 minus 0 plus 0 plus 0, which is 1. So we have get a finite volume occupied by these three vectors. In a real 3D space. Therefore, these vectors are linearly independent. These vectors hence form the basis of this three-dimensional real vector space, because they are linearly independent. So option A is incorrect because they are linearly independent. Option C is correct because they have formed the basis of R cube. Option B, that is they form the orthonormal set. We can easily see that the dot product between any two vectors are some finite value, they are not equal to 0, so we can easily say they are not orthonormal also. And option D, that is when we do this, when we compute this so we just compute this, so 1 0 0 times 1 0 0 plus 1 1 0 1 1 0. So we can just represent this equation in this form, 1 1 1 times 1 1, and when just do the matrix multiplication, you will get something like 2 1 0. I'm not doing this, you can just do it, which will not be equal to your three-dimensional identity matrix. So option D is also incorrect. So among all these four options, the option C is correct, that is these vectors e1, e2, e3, they form the basis of this three-dimensional real vector space because they are linearly independent. So thank you for watching this video.